Hi everyone, my name is Thomas Kim. Today is July 21st, 2019. This is my 7th episode about graph in C++. In this episode, we will learn about type list and std variant and std vector. Type list is missing in C++, so I implemented type list. In this episode, I will not talk about how to implement type list. Instead, I will explain how to use type list. Without further ado, let's get started. Start Visual Studio Code. If you open CPP extension folder, in the graphs subfolder, click 07 type list.cpp, hit enter. Ctrl V, Ctrl plus. Include talkplay fun, output HPP, talkplay fun, SS stream, auto, ender, talkplay fun, ender. Void test what is type list. int main template type name types args. So we call this function test what is type list. This is integer, this is unsigned integer, this is float, this is double. Okay, from this is argument, we can collect the types like this and make it into a list. Here I will create namespace alias, namespace types, talkplay fun types, then types type list. So types, we provide the types, this template parameter using types t. From this function call argument, these types are determined. Then we collect them into a type list. Then we can print out stream types of argument. Then types t, we create an instance, and now I start command prompt. You should be in CPP extension graph subfolder. We will be using Clang compiler, std, C++ 17, 07, type list cpp, hit enter, cls a. So types of argument, we provided int, then unsigned int, then float, then double. So this type list collects template parameters as a list into types t, then we display the types. Is type list any useful? Yes, type list is very useful. What can you do with type list? Well, modern C++, such as std tuple, std variant, std any, we can take full advantage of modern C++ programming language using type list. For example, from this type list, we can extract stream, the count of types, type count b, we provide type list t as argument. And we can extract first type from this type list using first T types select first type. We provide the type T as argument. Using second T types select nth. The index starts with 1. We have to provide a type list T. Using, we can select third type 2 types select nth type. This is third type types T. Or we can also use using last T types select last type types T. So we can print out the type first type play fun get type name first T and then string second type play fun get type name second T and then string third type play fun get type name third T and then string last type play fun get type name last T and then start command prompt. We rebuild CLS. So first type is int, second type is unsigned int, third type is float, last type is double. We can extract any information from this type list. For example, we want to know common type. Okay, from this type list we want to know common type. Using common T types common type T. Okay, then types T string common type play fun get type name common T and okay, then we can print out the common type CLS. So the common type of int, unsigned int, and float double is double. Now I will create more advanced case. For example, I copied once again this function name. How to use type list. So I will copy this function, paste it here. I will disable it. Now we call this function like this. I will just copy this list. From this function, we can test if it has common type. So using types T types type list types. We want to test if common type exists. If context here types common type B, okay, then types T here string common type exists Then we can test using command T types, command type, types T, talk play fun, get type name, command T, else stream command type does not exist. Now in this case command type exists. Okay, we run it. CLS command type exists. Now we apply another rule. I copied this. Thomas Kim. Now command type does not exist. Let's see. Command type does not exist. We can of course print out the type. Stream. The types are types T and L. Then we can print out CLS. So the command type is int, unsigned int, float, double, constant character, and the command type does not exist. We can also test if a certain type exists in the list. For example, stream is int in the list. Types is in list B int. This is type list T and L. Or we can also test if all types are the same. All types are the same. Types is same B. Types T and L. Is in list B. This function is very useful for advanced C++ programming. Now I will test once again. CLS. So is int in the list true? Because int is here and all types are the same, false. All types are different. Now I will try once again. Now I will provide all float 0. This is a float double. So I provide 3 doubles. Now we test this program once again. CLS. Now all types are the same, true. Is int in the list false because all types are double. Command type double. So type list functions are very useful for advanced C++ programming. I will create another function void test advanced type list. Suppose we are given a set of types, type list, int, short, double, constant character pointer, double, short, int. So we are given a list of types, int, short, double, constant character, blah blah blah. From this list, int is repeated and short is repeated, double is repeated. So from this type list, stream original types, we can print out types T. Now we can create unique types T, types, unique types T, so string, unique types T. Now we can convert from unique types to variant using variant T types to variant unique types T string the type of variant. To play fun, get type name variant T. Now I call this function, copied it, pasted it here. I build once again. Please note that we are using G++ compiler. In case of Clang compiler on Windows over MSys2 does not work for variant. So I'm using GNU compiler, CLS. So original type is int, short, double, constant character, double, short, int. From this list, we removed repeated types. We collected only unique type. Int, short int, double, constant character. So int, repeated int is removed, repeated short int is removed. We collected only unique types from this list. Then from this type list, we converted it into variant type. Okay? Now you are equipped with knowledge of type list. We can create really powerful container classes like this. Template, type name, class, container, type name, elements, types, class, container of variant, T, public. Now we are inheriting like this, container type. So this is container type, template type, types to variant T. Now we provide variant elements, types to unique types T. Now we provide a type list, element types. So we provided the elements type. This is for this angle bracket. One more. Now public using base type. I will copy this using base type. we created a very powerful container variant class. Now let's see how we can use it. I will copy this part. I copied it, pasted it here using vector over variance T. We paste it here. Container type elements types. We defined vector over variance. We can also define dq over variance. Now we don't need this. Here we can say std vector. Here we also don't need this. std dq. Now we can say list of variance std list. Also we can create set of variance std set. Up to this point, void test containers of variant. We will first try with the vector of variance. Vector of variance T int double constant character pointer float. Now we can try VB, vector over variance. VB in place back. This is integer. VB in place back. This is double. VB in place back. This is constant character. VB in place back. Sophie Turner. So we now print out stream VB and there. Now I will call this function, copy, paste it here. I disable it. We use Microsoft compiler, CLS, 2 unique types undeclared type. 2. I have to fix like this. Copy, paste. Now let's see once again. Okay, built. So integer, float, double, constant character string. This is vector. Okay. Now we can try with a list of variant. Now int double constant character pointer constant wide character T LB in place back. I will just copy this, paste it. Now here I use wide character. It should be LB. Now here stream LB and there. Now let's build once again. CLS. Now this is list. I can say LB. List of variance. I can say vector of variance. And we can also use set. I will copy once again. Now I say set of variance. I missed like this. In case of set of variance, less than operator should be supported. In case of container, std set operator should be supported. So here I will just say short like this, or LL long 6 LL 7 unsigned long. I will also put unsigned long. This is set of variance SB. Now here SB set of variance SB. Okay. Okay, in place back is not supported. It should be insert. Now let's run again. Okay. So set of variance, list of variance, set of variance. With this simple function type class definition, we created arbitrarily complex vector of variance, list of variance, set of variance. I hope you understand why I am emphasizing on type list so much. I will post complete source code to my website extension talkplayfun.com website. By the time you watch this video, you can click this link and download complete source code. Please subscribe to my YouTube channel. Thank you for watching.